When we talk about Soviet aircraft in the Cold War, we tend to focus on the industry's famous names: MiG, Sukhoi, Yakovlev, Tupolev. We sensibly assume that these organizations were broadly analogous to their Western counterparts. But the deeper one gets down the rabbit hole of Cold War aviation, the more one realizes that there are fundamental differences between the aviation industries on the two sides of the Iron Curtain, and those differences account for many of the successes and failures of each side in terms of combat aircraft design and manufacturing. In this video, I'm going to focus on the systems and structures of the Soviet aircraft industry. On the 28th of June 1918, Lenin nationalized Russia's aircraft factories. This was to a large extent pointless, as many of them had already been looted and burned in the ongoing fighting. Worse still, many of the managers and engineers had decided that it was best not to be in a position of authority and had either gone to fight, fled to the countryside, or fled the country entirely. But despite these immediate travails, Lenin's decree started the process that would conceive, design, and build the Soviet Air Force. One of the only surviving factories was the former Dux plant in Moscow. It had originally been a bicycle factory, converting to aircraft manufacture in 1910 and producing license-built French fighters for the Russian Air Force. As it was available and somewhat famous, it was redesignated as State Aircraft Factory No. 1, shortened to GAZ-1. With the government systems of Imperial Russia essentially destroyed, the new Soviet state needed to set up its own organizations. Given the obvious importance of science in modern armed conflict, one of the first to be created in June 1918 was the Scientific Technical Department of the Supreme Council of the National Economy. This was snappy and succinct, as was its abbreviation, NTO-VSNKH. Andrei Tupolev was amongst the small number of respected administrators and engineers that formed the executive of this new organization. He was also one of the advocates for the creation of a separate aerodynamic and hydrodynamic section, which was agreed upon in October 1918 and formally established in December. This was TSAGI, the Central Aerodynamic and Hydrodynamic Institute, based at number 17 Radio Street. It initially had a staff of 33 and was tasked to design gun and bomb mounts for the random collection of aircraft that the Red Air Force had acquired during the revolutionary chaos. From early 1919, they were also able to start work on their own research, using a wind tunnel looted from a university and various other scientific instruments. From 1921, Tupolev headed up the Aviation and Hydrodynamics Department within TSAGI, known as the AGO. Its responsibility was the design and construction of aeroplanes, seaplanes, aerosleighs, which is a kind of airboat, and fast torpedo boats. The department struggled to get the broken aviation industry into a shape in which it could actually design and produce an aircraft. Their first step in that direction was to sign a deal with Junkers to establish a factory for heavy aircraft in the Moscow suburbs. The intention was to both set up the factory, make aeroplanes on Russian soil, and start to train Russian workers to produce such machines. Doing that also entailed starting to produce aircraft-grade aluminium alloys in quantity. Soviet scientists succeeded not only in setting up a plant, but devising a new and high-performing alloy called Kolchug. Production began in small quantities in 1923 under the auspices of VIAM, another department within TSAGI. Simultaneously, a parallel organization was set up to develop aircraft engines, called SIAM, the Central Institute of Aviation Motors. The next task was to design an aircraft. This was very challenging, as there were only about 30 people in the Soviet Union who had ever even been involved in designing an aircraft. Only Grigorovich and Polyakopov had ever made an aircraft worth a damn, and none of them had actually entered quantity production. Tupolev himself, really an administrator by background, also started to dabble based on his experience with Junkers. To get things up and running, he picked out a number of designers to head up their own experimental construction bureaus. The acronym for this was, in Russian as you'd expect, OKB. To start with, at least, they were based at Radio Street, where a massive new development and construction facility was built in 1925. Amongst its facilities was the largest wind tunnel in the world. Although still chaotic, the quality of leadership in the early industry made it impressively progressive. Predictably, in this phase of the Soviet Union, Tupolov's success in getting early aircraft, like the Ant-3 reconnaissance biplane, the massive Ant-4 monoplane heavy bomber, and others built, meant that he was imprisoned, albeit briefly. It was significantly preferable to be connected and mediocre in the first decades of the Soviet Union. Getting aircraft from design to production remained challenging. The Junkers factory was taken over and nationalised as Gaz-22 on the 1st of March 1927, and other factories and material plants were gradually coming together. At the time, the only other aircraft design organisation in the Soviet Union was the Central Design Bureau, TSKB to the Soviets, at Gaz-39. This had been set up by the NKVD, one of the precursors of the KGB. In it were imprisoned designers that they judged to be questionably loyal but technically useful. It was run by Sergei Ilyushin, a skilled administrator and, like Tupolev, not yet a full-time aircraft designer. To accelerate progress, in August 1931, efforts began to merge these two organizations into one, creatively named TSKB Tsagi. In May of 1932, a reorganization of the merged entity began, creating a specific design department reporting to Tupolev and known as Kossos. Once this was done, Tupolev created OKBs to focus on the design of different types of aircraft. A couple of famous figures assigned bureaus at this point were Petliakov, in charge of large aircraft, and Sukhoi, who got fighters and aircraft intended to set performance records. In total, there were 9 brigades covering an eclectic mix of subjects, as set out in this table. The reorganization didn't last long. Ilyushin noted that the large entity remained unwieldy and proposed splitting out a prototype construction bureau at Gaz-39 and putting Ilyushin himself in charge of light aircraft development based there. TSKB therefore was almost immediately re-established, but free of NKVD influence. Heavy aircraft OKBs nominally came under the auspices of Tupolev and fighters under Ilyushin. Ilyushin's OKBs included Polyakov, responsible for fighters, and Beriev for seaplanes. He quickly came to the conclusion that further work on new aircraft designs would happen faster if the OKBs each had their own factory. Chizevsky and Beriev thus left TSKB and were installed in their own facilities at Smolensk and Taganrog, respectively. The remainder of the designers worked in what was effectively the Ilyushin OKB. Through this combination of actions, speed of design was revolutionized, leading to new aircraft types, most notably the Ant-40 high-speed bomber from Kossos, of which over 6,500 were built, and they formed the vast bulk of Soviet frontline aircraft strength in 1941. Stalin embarked on his paranoid purges in the mid-1930s. Somehow, Ilyushin avoided scrutiny, perhaps because of his history with the NKVD and his scrupulous commitment to decentralizing power in his organization. But in October 1937, it was Tupolev's turn. He was arrested and taken to Lubyanka, charged with the patently false crime of giving the Germans the design for the Bf-110. There he stayed until August 1938, when Beria himself assigned him to a makeshift design bureau in some sheds at a prison in Moscow. Eventually, they were moved back into their old offices, which were now a pseudo-prison, and they were able to carry on designing from the middle of 1940. While Tupolev was imprisoned, further changes were made to the way in which aircraft requirements were devised. The first formal body attempting to install some kind of strategic control on the defense industry was the People's Commissariat for Military and Naval Affairs of the Soviet Union. It was a massively powerful single central body for military command and control of the armed forces. Established on November 12, 1923, its first People's Commissar was one Leon Trotsky. As Stalin started the Great Purge, he went through a process of dissolving and neutering the stronger organizing bodies within the Soviet system. In June 1934, the Commissariat for Military and Naval Affairs was dissolved. Aircraft requirements were then supplied to Sagi and its satellites from an organization called NCOP, the People's Commissariat for the Defense Industry. NCOP covered every aspect of that industry and arguably none of them very well. So in March 1938, the Defense Committee, under the Council of People's Commissars, which is essentially the top level of the Soviet structure, formed the Aviation Council, an advisory body for the construction of military and civil aviation and aeronautics. Based on the work of this body, on January the 11th, 1939, NCOP was divided into 4 independent People's Commissariats, among which was the People's Commissariat for the Aviation Industry, otherwise known as NCAP. On January the 21st, the main departments, enterprises, and educational institutions were transferred to NCAP from NCOP. Its objective was to improve the planning and organization of the aircraft industry in the run up to the inevitable war with Germany and Japan. After the war, the Soviet industry received its last major reorganization and reached the structure it would remain in for most of the Cold War. Most significantly, NCAP was reorganized into the Ministry of Aircraft Production, or MAP. MAP had close control of the industry, including the aviation factories. Although their number designation stays relatively constant throughout, the way those factories are referred to changes during the Soviet period. Initially, they were GAZ and then the number. From the 1930s, they were Zavod, then the number tends to be used as well. After that, the way they're referred to varies. Factories are often referred to via their location, the factory name, and then some generic word, such as Gorky Machine Building Factory Sokol. I think this was mostly to give some love to the cities and regions, and also an attempt to confuse Western intelligence services. Around 30 factories built combat aircraft from 1945 to 1991, with some specializing on particular types of aircraft. Successful designs were often built in many locations simultaneously. The MiG-15, for example, was built in 8 different factories in a 4-year period, resulting in 9,300 single-seat aircraft in 2 versions. Tight compartmentalization of information resources in the Soviet system meant that it was hard for OKBs to access the latest science, use wind tunnels and computers, or obtain information about new engine or weapons developments without authorization from MAP. Their ability to pursue their own projects and thus advance the field was heavily constrained. In the boom period of the 1940s, 50s, and 60s, this problem was worked around by allowing multiple OKBs to develop flying prototypes and even short runs of production aircraft before a winner was declared and mass production began. Tasagi was also able to effectively hand full design concepts over to the OKBs for development into aircraft. The Su-9 Fishpot is probably the best example of this. It was a Sagi aerodynamic study based on data from the Korean War that Sukhoi was able to rapidly develop into a functioning aircraft. As the Soviet economy began to struggle in the 1970s, MAP took to assessing designs on paper much earlier in the process. Prototypes therefore became much better developed and more sophisticated as a result. But in turn, this meant that flawed ideas were now more difficult to back out of, and hence the Soviet Air Forces ended up with the MiG-23 family. As central control began to fall away in the 1970s, MAP's ability to coordinate the activities of the aircraft avionics engine and weapons designers was critically reduced. Furthermore, they were unable to optimize production, which was separate from design in the Soviet system. Overall productivity in the industry therefore fell further without any benefits from an innovation perspective. The severe conceptual flaws in the MiG-29 and the struggle to mass-produce the Su-27 can be traced back to these issues at MAP. But in saying all of this, it should be remembered that the Western military-industrial complexes were hardly perfect either throughout this period, although the freewheeling innovation inherent in the capitalist system ultimately proved superior to the rigorous planning of the communist one in aircraft development terms at least. There were many, many OKBs in the Soviet Union. Rather than go into all of them here, I'll focus on the key ones making fighter and light aircraft in order to illustrate how they were structured. 5 OKBs produced fighters during the Cold War period. In 1938, Semyon Lavochkin teamed up with Gordonov and Gutkov to produce the Lag-1 and Lag-3 fighters. These were followed by the successful LA-5, but by the end of the war, Lavochkin's partners had moved on. His design bureau then designed a long series of jet fighters, but very few production aircraft saw service. Lavochkin died in 1969, and his OKB was turned to missile and spacecraft design. In 1939, Artyom Mikoyan was asked to form an experimental design bureau, an OKO, within the Polyarkov OKB. He was there to develop a new fighter, but was only willing to do so if his close friend Mikhail Gurievich was allowed to join him. The pair produced the delicate but unimpressive MiG-1 Interceptor, and their piston-engined aircraft were consistently uninspired. Their jets, however, launched a dynasty that continues in some part to this day. Pavel Sukhoi learned his trade in aircraft design under Tupolev. He was able to form his own OKB in September 1939, but it wasn't until the end of the war that his designs really began to take off, as it were. Unfortunately, Sukhoi fell out of favor with Stalin in 1949 and his OKB was taken away, but on Stalin's death in 1953 it was reinstated and Sukhoi would grow in prominence until his own death in 1975. Mikhail Simonov then took the OKB to new heights, culminating in the Flanker series. Alexander Yakovlev was the most successful of the wartime fighter designers. Another late 1930s recipient of OKB leadership, his lightweight and fast Yak-3 was probably the best Soviet fighter of the war. Yakovlev's jets were much less successful, but the man himself was very well connected politically, particularly to Stalin. He therefore tended to be able to shape aircraft design policy in his favor. He was also instrumental in Tupolev's imprisonment for political unreliability, which further alienated him from the other designers. Younger than his contemporaries, he died in 1989. At the top of each of these OKBs was a chief designer. Initially, the OKB was eponymous with that individual, but as those businesses became more established and as export sales became more important, the OKB names were retained when the founder died or was otherwise incapacitated. The chief designer's work was monitored by an inspector general, who was usually a retired military officer. This job was one of quality control, but also retained a kind of monitoring of political reliability. This person was the Ministry of Defence's stooge, as it were. The chief designer had a deputy to assist with the workload and an expediter whose role was to plan work within the OKB, kind of like a chief operating officer in the modern parlance. Operationally, the OKB was split down into 5 departments, the most influential of which was technology. Usually headed by the first assistant chief designer, typically an up-and-coming designer himself, it was further divided into 2 pieces. The design teams were mostly responsible for development of discrete parts of the aircraft, like wings, landing gear, and controls. The exceptions were the configuration team, who were in charge of integrating all of the pieces into a whole, and the dynamics team, who worked with flight tests to figure out how to improve the way the aircraft flew, in combination with the other subteams. The other branch of the technology department dealt with an underappreciated part of the design process. They developed technical standards and tools that enabled the other designers to do their jobs more effectively. Things like running the laboratories and the technical library fit in here, alongside planning and administration. The latter were even more important in the Soviet command-based economy than they were in a capitalist system. Although the technology department was the heart of the design process, overall design authority for a complete aircraft was actually the remit of the projects team. This small group was responsible for turning the chief designer's vision into the overall blueprints and then aligning the work of the various departments that would bring it to life. For most of the Soviet period, OKBs were relatively low on manpower, meaning that they were rarely capable of executing multiple projects simultaneously. Their situation was more akin to that of British than American manufacturers in this regard. Both technology and projects would necessarily work with the production design department from an early stage of the process. Production design was vital in the Soviet system because the OKB's design would be passed to the third-party factories and the makers of machine tools, often located thousands of miles from the design team. A brilliant aircraft with exquisite technology wouldn't fare well in this environment if it wasn't reduced to words of one syllable on the production line. Once a project had been fully designed and those designs had been approved by MAP, they entered the domain of the prototype department. This was the largest department in terms of manpower, mainly because it contained the more practical engineers and apprentices that built the various static and flying prototypes, as well as the people who maintained the OKB's facilities. The prototype plant directorate was usually divided between engineering, facilities, and general personnel. Being the plant director made you a combination of operations director and HR director. Finally, there was the flight test department. Presumably treasury and catering sat in this one, to furnish wadges of rubles and bottles of premium vodka at various milestones. In parts, the Soviet system for aircraft procurement was similar to that in the West. Ultimately, aircraft stem from requirements set by the Ministry of Defense at the top of the system, the head of which sits on the Politburo itself. MAP would then devise performance and economic specifications, which were passed to TSKB. They, in turn, instructed the OKBs about the format of the required aircraft. In the early years of the Cold War, multiple OKBs would be invited to propose ideas, but as I said earlier, from the middle to late 1950s, it was more typical for just one organisation to be instructed. This is where the system deviates substantially from those across the Iron Curtain. In order to reduce wastage, very little flexibility was given to OKBs to devise concepts that met the specification. Because of the large number of scientific advisory bodies that existed around the OKBs, there were further restrictions on their abilities to operate. There was experimentation, but because the OKBs needed to obtain all of their resources from the centre, each had to be individually signed off, usually by multiple bodies, just to get a prototype or an experimental idea off the ground. The shared science and research could, however, be advantageous sometimes. Western companies naturally relied on trade secrets to give them competitive advantage. That meant relearning the same things multiple times across multiple organizations. Sagi, in particular, often solved problems for everyone. Wing fences to stop span-wise flow and the engineering behind variable sweep wings are two good examples of where the central organization saved time for everybody. A different kind of secrecy was a big issue for Soviet designers, though. The development of aircraft, engines, avionics, and weapons were the purviews of separate organizations, just like in the West. But whereas there was a degree of cooperation between those commercial operators in the West, the Soviet system's inbuilt hypersecurity and paranoia impeded the development of integrated weapon systems. One also had to be very careful not to criticize the wrong person in assessing the real performance of a system. I'm not saying that the Western system was perfect in saying all of that. Where the Soviet system had overbearing control and paranoia, the Western military-industrial complex suffered from changing politics and industrial policies as governments came and went, and the inherent wastage that comes from many organizations bidding on contracts. And of course, for the most part, aircraft and weapons development in the West was a private sector endeavor. Shareholders want their profits. One area in which the Soviet system was arguably superior, at least in the early days, was in production. Because the factories were separate from the designers, multiple factories could be directed to make the same aircraft, enabling massive production runs. That did happen to an extent in the UK and US, where various procurement organizations would direct manufacturers to go into larger or alternative facilities to increase capacity. Vought moving to Texas immediately springs to mind. Politics and individual freedoms meant that those moves were not necessarily as fast or as systemically optimal as they might have been, though. It's worth saying that factories were separate from designers to a greater extent during the First World War and immediately afterwards. State-owned arms manufacture was a lot more common in that period, but was largely abandoned for aircraft in the rapid disarmament that happened during the 1920s. In hindsight, it isn't hugely surprising that the Soviet system was structured in this way, but it must have been quite hard to grasp in the Cold War, particularly for the amateur enthusiast. When one thinks about MiG or Sukhoi, it's just very tempting to see them in the same light as more familiar organizations like McDonnell or Hawker. But as I've hopefully showed, they were very different organizations with different challenges and roles in the overall system, not least avoiding being put into Lubyanka. We glorify the names of the Soviet companies and their designers, but their actual importance to the overall maintenance and development of the industry was less than that of Western aviation companies. The system, however, was formidable.